A surface may be perfectly flat, but if the linear elements running across that surface are bent, the part will still cause problems. A shaft may have slight bending bearing vibration increases. A linear guide may have a wave along its length, friction becomes inconsistent. So this time, the problem is not the surface itself, but the directional straightness of the line on that surface. Today, we're talking about the second fundamental form tolerance, straightness. Straightness is the requirement that a linear element on a surface, or an axis, must lie between two parallel lines. The distance between these two lines, the tolerance value, defines how much deviation that line is allowed to have. For a surface, any linear element taken along the surface must remain straight. For a shaft or a hole, the axis must progress without deviation. Straightness does not control the whole surface. It targets a single linear element. Flatness keeps an entire surface between two parallel planes. Straightness keeps a single line between two parallel lines. A surface may appear flat, but a linear element on that surface may still be bent. If an axis has even a slight deviation, the diameter may be in tolerance. Yet the assembly may still bind or drag. In other words, straightness protects not the surface, but the direction itself. The straightness symbol is written alone in the feature control frame and does not reference datums. Because the controlled feature is a line or an axis, it is not positioned relative to something else. As in the example, it means that the linear element must lie between two parallel lines 30 micrometers apart. For surface elements, the tolerance zone is two parallel lines. For axis straightness, the tolerance zone can be visualized as two coaxial cylindrical surfaces creating a thin, straightness sleeve around the axis. Straightness plays a critical role especially in moving or rotating systems. If a shaft is not straight, bearings wear prematurely. If a linear guide lacks straightness, friction force fluctuates. If a hydraulic piston rod is bent, sealing components deteriorate quickly. If long parts come out of grinding with a slight banana shape, side loading appears during assembly. In short, when straightness degrades, the system experiences unwanted loads and energy losses. Straightness can be measured using a variety of methods. Classical method. The part is placed on a surface plate and a dial indicator scans along the line. The difference between the highest and lowest readings is the straightness value. CMEM method. Points along the line are collected and deviations from the ideal line are evaluated. Axis straightness measurement. The axis of a cylindrical part is compared against a theoretical axis. The tolerance zone is imagined as a thin cylindrical shell surrounding the axis. Straightness tolerancing gives the designer several advantages. Ensuring function without forcing overly tight dimensional tolerances. Controlling bending risks in long parts. Preventing friction spikes, binding, or vibration during assembly. Maintaining directional accuracy in bearing seats and sliding surfaces. Tightening a size tolerance is not always the solution. Clearly defining the linear form is often far more effective. Common mistakes when applying straightness include confusing it with flatness, adding unnecessary datums, using runout instead of straightness on cylindrical axis, specifying a tolerance that conflicts with logical size tolerance limits. A production line is experiencing repeated premature bearing failures. Shaft dimensions are correct, diameter tolerances are within limits. But the shaft axis was slightly bent during grinding. Total deviation was 60 micrometers. When a 20 micrometer straightness requirement is added to the drawing, vibration disappears. Bearing life triples. Energy loss decreases by 12%. Straightness is one of the fundamental building blocks of form tolerances. Without understanding straightness, it is impossible to fully understand axis alignment, runout, or profile controls. In the next lesson, we'll move on to the other form-related topics. Subscribe and follow the series, because the right tolerance leads to the right behavior and the right performance.